I'm going to open also the brackets.
Let's see if they can see it in here well. Camera looks okay. Sound looks okay. Are we good? Let's see, because there might be a lag. So last time we had like a 6-second lag. Let's see. Yeah, the sound should be okay. Can you try?
It's loading.
Still loading. Okay, looks like they're hearing us well. The stream, we only get a black stream. I throw my monitor out of the window.
No.
Well, it should be.
Now I can see you. It's still loading.
Should be fine. Should be fine. Okay. Yeah, is it good?
Yes.
Can you guys hear me okay? How about the video? Is that all the hook? Not really. Actually, we still have some hooks on the way, but most of them 80 hooks. 50 hooks. Yeah, we won't be able to talk about all the hooks, but I think all the interesting hooks are here. All fine. Okay. Well, I guess we can begin. If there's any issue with the sound or the image, you can just let us know on the chat. So there is Oriana on the side here that is going to monitor the chat. If you have any question, just to make sure I don't miss. I also have the chat in front of me here, so that we try to not miss any questions. So I'm not sure what is the lag at the moment. Usually it's around like 6 to 10 seconds, but we'll try to keep up with that. So so my name is Nicolas. I'm a 3D printing engineer at Polymaker, and Oriana here is our designer and campaign manager. So I guess most of you have talked with Oriana over the last month to make sure all the campaigns goes well, that your hook arrived okay. So I think at the end we had around 181 participants. So it's much more than what we expected, but I think that's gonna give us a very good tournament. So as you can see in front of me, I have all the different hooks we have received so far. We have some in our other office as well that are going to prepare for the for the battles. So from America, yeah, most of them are from America, because we had some hooks that had a posting issue, and we wanted to group them before sending everything to our headquarters here. So yeah, so maybe we can start talking about a few of the hooks. I saw a question, why is it taking so long for the competition to start? Yeah, so you know, there were a lot of logistic issue, especially a lot of people send the hooks to our different hubs. So we had one in Japan, one in Australia, one here in China, one in the US, and one in Europe. And the one in the US had almost 10 or more than 10 hooks that arrived 2 or 3 weeks after people have sent it. So we had to wait for all of this hook before sending everything back to the headquarters. So that's why it's taking a lot of time. But now we're getting ready. We have all the machines that are ready in our other office. Okay, so we have, I was actually taking in my hand this design, because it was like kind of standing out of the other. You can see this design, very, very interesting design. Maybe, do you think we can move the light a little bit there so that they can see properly?
Sure.
Because this one is Very interesting one. I don't know how they have designed this one. I guess using like some kind of software that would, you know, like this kind of organic design that will like iterate and then change, automatically change the design. But yeah, that ended up in a interesting hook. I don't even know where I think these participants send us also where to put the hook, but I believe it should be something like this. Do you remember? Yeah, you can put it in, then we can see. Oh yeah, like this. Yeah, correct. So yeah, the hook would be put like this. So very interesting design. I wonder if mine is there. Well, do you remember the color? And then already from the color we can check if it's somewhere around here. I didn't see my name in the bracket list, but I received the email that I'm in.
I'm checking on him.
Okay. Yeah. So Oriana is checking on your hook just to make sure that is part of the brackets. US mail is underfunded by. Okay. That's why. Okay. Yeah. So yeah, like we said, a lot of logistic issue, but definitely we'll start posting. So I think 2 weeks from there, because we need time to do all the different battles, and we also want to take some nice video of the battle so that you can clearly see where the hooks break and how do they break, how do they behave under tensile, so under the tensile strength. So we want to make something clean so that you can really see how your different hooks perform. And we'll start posting in a Tuesday in 2 weeks, right? 2 weeks from now. So 2 weeks from now, every Tuesday and Thursday, we are going to post all the video of the different battles. And yeah, every Tuesday and Thursday until the final. And then around the quarter, we'll start. So we will rent like a slow-mo camera, so you can really see the behavior of the hooks that would reach that limit. Also, a question that we've been asked a lot is about our hook. So we actually purchased a different hook. So the hook design is the same for the metal hook, but this one can support up to 800 kg, right? So 800 kg should be enough for most of the hook, but we did receive hooks where the participants said that it would go over. So we also have some backup hooks. They are not exactly the same design, but they are like a closed hook, like kind of a quick link. So yeah, just in case we have any hooks that go over 800 kg.
We also have the rope as alternative.
Yes, and the rope, because we know there is a couple of designs that have a very specific shape where the quick link may not fit. So we have a climbing rope just in case. But hopefully this hook will be good enough. Setting up the constraint for topo optimization is really challenging. Yes, definitely. How many battles every time? So at the beginning, there will be. So we will group all the battles because we are talking about 100. If there is 181, there are 181 battles, right? Mm-hmm. So 181 battles. So that's a lot of videos. So at the beginning, for the 64th, the 30 seconds, the 16th, the 8th, I think the 8th, then it will be like grouped battles. And then from the quarters, semi-final and the final, then we will have like single videos that really go in depth in how the hooks perform and how they either break or let go. We can analyze this with the slow-mo. If the hook doesn't fit, then are they not disqualified? Yes. So actually, we already tested most of them whether our hook fits, and I have to say that most of them are okay. Some of them you have like to press fit the hook inside, which is fine. So as long as we can put our hook inside, then it's fine. So for example, you can see this one. You have to oh yeah, like this.
Yes.
You see, you have to kind of press fit the hook inside, but as long as it can hold inside, then that's fine. We can proceed to the tensile test. Yes, but you mentioned something about the rope. Yeah. So what I mentioned about the rope is if the metal hook is not strong enough compared to the printed hook, then we have climbing rope, which will be so depending on the grade, but the rope will be stronger than the hook itself and will close on itself. So why we choose a rope as a last backup solution is because we have a lot of design that are highly dependent on this shape. So the good thing with rope is that it's flexible enough to kind of fit any shape that the hook would require, which should be exactly the design we've shared of this metal hook. If the metal hook doesn't fit, it should be disqualified. Designing to fit the hook was a big challenge. Yeah, definitely. This we agree. You know, we have a lot of hook. I've seen one. Yeah, for example, this one. I think this hook was from Race 3D. So this is the Race 3D hook, and so you know the Race 3D office is very close from ours, and they explained to us. So when I received the hook, I was thinking, you see, like there is still some space between the hook, and usually the idea would be to have the two metal hook very close to each other, and then use all the materials to get around. But what they explain is that they had to make sure that the hook would actually fit. So definitely it was a design constraint, which means any hook that didn't take this constraint into account then will be disqualified. But so far we haven't found any hook where we cannot easily put the metal hook. So I think pretty much everybody followed that rule, which was good. And talking about rules, yeah, I know we had a couple of edits in our articles. So the very first rule was so it was more about like the post-processing and the no holes. So where these no holes come from? So at the beginning, when we wanted to do the campaign, it was more like whatever hook. So you could even like just print like a closed loop, and then we were thinking, at the end of the day, if we do this kind of contest, what most of the people would just print, you know, like just many shells and just the printer just spinning and just doing this quick link, very, very strong one, and then everybody would have a very, very similar design. So there won't be much creativity. So then we were thinking, how about we have to have an open hook, and by open means you cannot have any complete hole. So complete hole in a CAD design way, right? So if you have this in your CAD software, and then you select one vertices from one side, and you link to another vertices from the vertex from the other side, then you would have to go all the way down. So you cannot cross this section because it's open. You know, so that's what we mean by open. And I think everybody kind of understood the idea. And the other way we wanted to, so the other reason why we wanted to have the open is that to have this kind of, you know, creativity that would impact as well as kind of ingenuity. So we have a lot of people that had, you know, like, for example, this hook, which is a very well-known shape for a very strong S hook. But so the idea would be to have, instead of having everyone, you know, following, you know, these rules about designing S hook, we would have people coming up with very, very interesting ideas of most of the time is self-locking hooks. So that was the other idea behind having this rule of open hook. And I think it kind of I think it worked because we really have many different designs. So you can see this design, which I think is one of my favorite. There is a couple of them that are like this. This one. So you see they are all following the same idea. So the idea is that you see it's kind of like a spiral So the idea would be to have, I will leave it open, but you know, so how to say that? Like 3D printing in a way is kind of open, where it just continuously make lines and lines and lines, but they kind of fuse together. So they follow the same idea, but they just put a little bit of space in the middle, so that is considered as open. But at the end of the day, I believe, I'm not sure, we have to test it, but I believe these kind of hooks must be quite strong. I think so. And then there might be some. It might also depend on how they have chosen to close the hook, the loop at the end. You see, like this kind of. There's a small hook here, so I'm not sure if this will resist. But what I'm thinking is that you are kind of dividing the force by the number of layers, I guess. So that means the small hook at the end would only support like 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe 1/9 of the force, I guess. But yeah, so I think this idea is great. And then these participants have decided to self-lock his hook by just self-locking on the hook itself. So you see, this kind of hook really need the S hook. So let's see if this hook can go over 800 kg, which is the limit for this S hook. And then the last one was this one. So this one, there's also the same. There's a tiny hook here, but then the force would be divided by 1, 2, 3, 4. So I guess 1/4 will be bear by this this hook. Did I miss any question?
No, not so far.
Hooking onto the metal hook is genius. Yeah, I think so too. Yeah, this hook, which is like self-locking on the metal hook, I think is a very good idea. That green one is definitely winning though. My hook is cone. Okay, I don't remember which one is called cone.
Looking for it.
Relying on the elasticity of the material with that design. There are not even hooks, just open loops. Not all of them have arrived, I believe. Yeah, correct. Not all of them have arrived. However, they are all in China at the moment, but we have one that is still in our other office. All those hooks, the contestant? No, definitely not. I think we have 50 here, and in total, we have more than.
This is cone.
This is cone hook? Okay. So, yeah, here's your hook. So, what's the name? Lucky Larry. So,
No.
here's your hook. So,
Joel.
is that? My hook is
sorry,
cone.
no.
Yeah, Lucky Larry. So, yeah, definitely one of the biggest one.
Sorry, that one is from Hong Kong.
Oh, from Hong Kong. Oh, okay.
Lucky Larry. Sorry, Larry Taylor.
Yeah.
Is in our other office. Hasn't arrived.
Okay.
to this
Hasn't
office
arrived yet.
Yeah.
But yeah, I mean, we can talk about this one. You see, you have where is that one? Yeah, you have tiny hooks, and you have huge hooks. Like even this one. I mean, this one is huge. These I think are the two biggest one. You have this one, and maybe this one. So there's a huge difference in size between all of the hooks, and similar to this one also. You see, this one is very tiny, which is what we were talking at the beginning, right? I think having the two hooks touching each other and using all the materials to reinforce that link, rather than maybe having materials just to close that gap. Maybe it was the good idea, but as we discussed, there is this limitation of not being able to reinforce these two parts, because then it would be too big to fit in the metal hook. So you can see that this contestant has designed like a cutout on both sides, so that we can easily put the metal hook, and then he used the extra material here to form his self-locking mechanism. So actually, if we have to, it would be great. I don't think if we have this percentage yet, but there is, there's different kind of design. So if we had to like group them, there would be, so there would, the first, so let me just check if I've missed any question first. 220 kg together, I'm tweaking. Is my hook here? There, it is orange. Not sure. So we have 3 orange hook. So is it one of them? Actually, look at this hook. Very, very interesting. So you have to, so this hook you have like to fit. So you see, you fit the metal hook inside. And yeah, so I'm actually not sure how this one will perform. Like, do you think it's a good design in a way that it's using all the materials towards like resisting the tensile strength, or do you think there is some materials that may be not wasted but won't participate into helping countering this tensile strength? But I think it's a very interesting design. I don't think we have received. We may have maybe two or three designs that are similar like this. So first, they take a big risk, right? So we did share the 3D model of the hook. So I guess they just remove that 3D model from their block, and I guess add a small margin because we can press fit our metal hook inside. So yeah, sorry, I'm looking at my screen at the same time. I'm not looking at the camera. Yeah. So here's the hook. So very interesting one. But let's go back to the different category, different design category. So the first one definitely S hook. So here we have 1, 2, then 3, 4. I think that's one of the biggest category, the S hook. 5. So 1, 2, 3, 4, 5. Then 6. Yeah. So you see, there is still the support on this hook. But I'll come back to this post-processing rules after. So just yeah. Any question?
You mentioned about what our contestants are saying. We receive all CNC kitchen, but they are not in this office yet. But we have received.
Okay. Yeah. So we have received all the CNC kitchen hook. I think this is the CNC kitchen hook, right?
No, but that one he sent it himself.
Okay. So this is his hook, and then he also sent. Yeah. So the hook that he printed for his community is not here. I'm not there, but his own hook, which I think is this one, right?
I believe so.
Yeah, so it's this one. So I know a lot of people are waiting to see how a CNC Kitchen hook will perform. So for those that don't know CNC Kitchen, which I think is known, so he's a YouTuber that is more on the technical side of 3D printing, doing a lot of useful tests, and he actually made a video to help the community to print their own hook. So he explained a few trick and tips. So his hook. So I have to say it's pretty heavy. Let me check. It's pretty heavy. Is what 49.82.
That's risky.
So he's really at exactly at 50 grams. Because we have some hook that took a large margin, right? I've seen some hook. What is this one? This one is at 47.8. So there is still 10 grams of, what do you say? Yeah, 47. Yeah, not bad. But there is some, like this one, I guess is pretty, yeah, look, this one is 18 grams. 18 grams. Yeah, there's a lot of materials that could have been used, I guess, maybe making it thicker, because I think even on the, it fits perfectly. So I guess this participant could have put extra materials on it. But yeah, coming back to the CNC Kitchen, where did I put that?
There's
here. Yeah.
one question.
Yes.
So is it going to be 51 the limit to compensate for different scale occurrences? Yeah, we can go one gram.
Yeah, it's plus.
Okay.
Yeah. So 51 is fine. You know why we want so we we know that our participant put a lot of effort into printing these hooks, designing, iterating. So we are making our maximum to make sure that everyone that wanted to be involved can have their hook on the tournament. We have received hook that didn't follow or maybe were above 51 gram. So we contacted them and we offered them to print the hook for them so that they can iterate, because we want to stay fair for the other, but we also want to stay fair for them because they put some time into it. So we're trying to make sure that everyone that wanted to be involved have their hook in the competition. Yeah, so that's it for the Stefan's hook. So CNC Kitchen, very interesting design. You can see that there is a large design difference between all of them. You see, some people have decided. Let me check. For example, for example, this one. You see, when they are going to push or to pull the hook apart, it may deform. Deform this oval shape, right? But a lot of other. So same for this one. You see, as the hook is much thinner, it will deform the oval shape, which may be to design it, you just make a circle and then you create the shape. But I've seen some comments on one of the YouTube video that were explaining that the circle might not be the best solution, which I agree. I think the best solution is to exactly match this the thickness of the hook, which was 1 millimeter, and I guess so. CNC Kitchen is the solution he went for, and many other. You see, this one is also the solution he went for. So exactly 1 millimeter gap in between. But you see, some other one they didn't go for that 8 millimeter. I'm not sure how it will perform, but my guess is that it will deform the hook, so create additional stress that would be in a different direction. Okay, coming back to the different category. Yeah, let me know if I missed any question. So I was at 1, 2, 3, 4, 5, 6 different S hook, and 6, 7. So yeah, there's another thing that is interesting is the way participants have printed their hook. We have some participants that have still used like maybe 3 shell and then a certain infill, maybe rectilinear infill 20%, and then top and bottom layer, so like kind of the common setting. And then some people that have worked their setting towards having a stronger hook. So you can see this one. Let me see if I can. Yeah, you can see the reflection here. So this one have used concentric infill, and so whether you have top layer or not, it doesn't matter because it's kind of concentric all the way. And I think that was, I think this is very smart because it kind of have all the, the line just parallel to the strength. So to the stress. So I think that's a very good idea. So 1, 2, 3, 4, 5, 6, 7. Very interesting hook. Again, you see, the participant went for a circle, but yeah, let's see, because you can kind of predict how. Yeah, if I put here, perfect. So you can see how they how it will deform, right? You have a couple of hook which I don't think will break, but they will just let go, and that was also something to consider, right, during the design process. Yeah.
There's one question.
Yes, one question.
How do you make sure that hooks are made with Polymaker Polymax PLA and not any other brand plastic?
Yeah, how do we make sure that they are made in Polymax PLA? Very good question. My first answer would be just trust. So that's the very first one. So we trust that in the 3D printing community, we have people that would be involved and be fair to other. Second one is color. We did receive hooks which use a totally different color than the one we offered. So obviously we know it's not Polymax PLA, but that was not, it wasn't made on purpose. He knew, he didn't really read the rules properly, and he just printed another one in our Polymax PLA. So it was like a kind of sparkle green, which we are not offering with Polymax PLA. Another way we can define it, but it will be during the battle. You know, the behavior of Polymax PLA is very different from the one from Polylite PLA or any other regular PLA. However, if someone used another kind of tough PLA, then it will be hard to see. We could do every single hook after the contest. We can just cut a piece of it and then run a test to know if it's Polymax PLA. But you know, we hope that the community would be fair, and that they are not. We don't think that in the 3D printing community would have people that would purposely use a different material, or I don't know, put some carbon fiber inside, hidden inside that we cannot see. We believe that people have played along with the rules.
Yeah, it's the spirit of the game.
Yes. I think it was the 3D printing community, I think, has a good spirit. So I don't think we'll have this issue. And definitely all the teal one should be definitely Polymax PLA, because I don't think there is any other tough PLA that offer our company color. And also every color, are very, for us, if we're very, very, how do you say that? Familiar with our colors, then we can easily distinguish if it's our orange or another orange, if it's our blue or another blue.
Yeah,
so,
the one we got was green, and it was off. The color was off.
Yeah, we had a hook that were green, but we could see that it wasn't our Polymax PLA green. And also because we do produce consistent color, so they should be all the same. Okay, coming back. 1, 2, 3, 4, 5, 6, 7. So I think that's it for the one more hook. That gives 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think that's it for the S hook. So that's, let me check. Yes. So that's one kind of design. So all the people that design an S hook, and I think in terms of percentage, I think that was one of the biggest one was the S hook. Now the different one is the C hook. So we also received a lot of C hooks. You can see this one. I think there is a couple of other ones. This one, you see, C hooks, and then
we're getting from the community saying that we should test the winners.
Yeah, definitely. This we can do. Actually, the 3 winners. We have 3 prizes. So the 3 winners, we can scientifically test whether the material was Polymax PLA. That's a good point. Another S hook. C hook. This one, I think that was from Race 3D as well, right? So I think another team.
That was from another person from Race 3D, yes.
An individual, because in that competition we could have the company that would put their logo and on their hook. So that was the Race 3D one, and then individuals. So from they are working at Race 3D, but they are entering the contest as individual. So they do not represent Race 3D. So we received this hook. So yeah, it would be very interesting to see which one would win between the two, because one is representing the company, one is a person within the company. So very, very, very interesting.
We have 2 interesting questions.
Yes.
So, do the pigments affect the properties of the polymer?
Will the pigment affect the property of the polymer? Theoretically, yes. But I think it's negligible. If you take exactly the same design of 2 different colors, so let's say, I'm not sure which dye, but there is some white paper that says that I think pink, green were the worst one. I don't remember exactly, but I think it's very negligible. But that's something we could test. Actually, we could, after the competition, we can have like 2 hooks in 2 different colors, and then see how it performs. Because you see, that's also something. If you test exactly 2 exactly same hook, which one would win? You know, like if you repeat it 100 times, it would be interesting to see like whether any defect in the part. So I guess it would be dependent on any defect on one of the parts, and that's also something that the industry is trying to solve. You know, to use 3D printing in manufacturing process, we need to be able to print exactly the same parts over and over.
There's another question.
Yes.
Brian Bartlow asks us, are you going to post pictures of each hook at some point? Yes.
Yes, we will. So actually yesterday we had the first shoot of all the different hooks, and then we are putting it on a poster with like the country, the name, and then we'll post, we'll have some album on Facebook, and then we'll have also some group of pictures on Instagram. So you can go on our social media and then see exactly how they designed every single hook. Any other question I missed?
Not so far.
So minor under extrusion, temperature changes in the room, etc. Yeah, that can also affect the performance of the hook. Okay, so let's continue. Yeah.
To say fewer questions, more hooks.
Fewer question, more hook. Yeah. I'm coming to it. So S hook, C hook. Let me check if another C hook. Interesting. Polymaker and LJ. Polymaker and LJ. So another interesting C hook. And then so you can see there is some C hook which put all the material on one side. So definitely this one put all the material on one side, and some other that were just like a little bit more consistent along the C hook. So we can also subdivide this one. You know, those with like a huge mass of material on the side, and those that are more even. Any other C hook? Not yet. Question?
Yeah, question. So what did it look like? There were already some hooks in round 2. Would the hook they faced from round 1 already be weaker? So that's also why we asked for 3 hooks.
Oh, yeah. So how it will work is this one. So we asked for 3 hooks. The reason is at the beginning we wanted to have only 1 hook and then go all the way. So the idea would be that he have to have like some kind of durability because he would have different tensile strengths over time. And then we were thinking maybe for the semi-final and the final, we should have a brand new hook for both parts. So what's going to happen is every participant sends 3 hooks. So 1 hook will be used until the semi-final. And then at the semi-final, we will use a new hook. And then at the final, we will use another new hook. So that's 3 hooks. And then at the final, there will also be, how do you call that? Small final, like the final for the 3rd place that will use the 3rd hook. And then that means we will have a lot of hook that would may die or like break at the 1st round. So, or maybe 2nd round. So it means we will have a lot of hook. So after the competition, we will have some different tournaments between the different hooks, just to not waste the hook, but see what if this hook would be against the other hook, and kind of have like a final ranking for everyone. But there might not be like an accurate ranking, but we can be more accurate by using the extra hook to test each other. Okay, so it was easier to debug than Hacker PLA. I think so too. Okay, so let me continue. Last question, more hooks.
There's one question that Dove has asked 2 times. So why did we choose a bracket system?
Why did you choose a bracket system?
Because of the tournament.
That's a good question. Like over which system? Like a soccer tournament where you have like group at the beginning and then brackets, or well, we feel that the tournament was more exciting. You know, like a single elimination. So that means in every battle you have the suspense, because if it breaks, then you're out of the competition. So that, I mean, that's the principle of single elimination tournament. So we thought that it would create more suspense, more excitement around the competition. So I guess that's why we have chosen the tournament bracket style. Any other question? No. So I want to watch destruction. Yeah, I think you're going to watch some good destruction. Actually, some of the hooks are so strong that even being Polymax PLA. So I will come back to why. So I need to come back on post-processing, and I will come back on Polymax PLA. So maybe can you record this so that I don't miss? Yeah, I will come back to this. But you will see destruction for sure. So no more. Oh, sorry, one more C hook here. So that was also a smart move. You see here, he cannot have holes, so he didn't go all the way through, but he carved through on both sides to save materials. Because I guess I'm not a like mechanical engineer, but I guess the further apart this part is, and maybe the more efficient it would use the material during the test. Yes, and I think we have another hook, which is not here, but which is from Teton Simulation, another company hook, and I think they have chosen to go for. So Teton Simulation is they have a product that is called Smart Slice, and allow you to put a design, and then the Smart Slice would automatically tells you the right setting to match your requirements. So you can set the requirements like in terms of stress and some like safety factors, and then they will tell you, they will automatically calculate the right setting. So yeah, so I think their software was very, very useful for this competition. However, this software only takes in account an already designed hook. So it can tell you, I think it can tell you where you have the most stress, and I guess you can reinforce that part. But yeah, I'm looking forward to show you also their hook, which is a C hook, but a very, very particular design on the side. And they were very smart because they made a hole, but they covered the hole with a thin layer of plastic, so like the first layer. But yeah, stay tuned on the social media to see their hook. Because it's a very, very smart design. So they kind of bend the rule in a nice way, which I really liked it. I liked all the design that kind of bend the rule because I think that's like the creativity, the creativity spirit of that tournament.
Two things, Nico.
Yes.
So you have to go back on Polymax PLA and
Polymax PLA and post-processing, the post-processing rule.
So they're asking if our goal was to sell more PLA. So that's why we asked for 3 hooks. So we can. Okay.
Yeah. So we had a lot of people saying that the tournament was for us to sell a lot of spools. Definitely not. Well, you can make a guess, right? Let's say every single participant have bought a spool. That represents 180 spool. Let's say 200 spool. That's definitely not very, how to say, economically viable compared to what we put into this. So the goal was not to sell more PLA. The goal was to have a contest that will link Polymaker to their community by having the community involved in some kind of design contest slash creativity slash ingenuity slash excitement, because we would do all the battles, we would take nice video. So definitely not selling. So why we've chosen Polymax PLA? The first reason is we had to fix the material. You know, not everybody has access to continuous fiber printing or PEEK or any, actually PEEK wouldn't be the best one in this case, but not won't have access to a high performance material. So we had to define one. Now we can say, okay, then why you didn't define just PLA? Because there's many different kind of PLA. You know, you could have PLA that is way stronger than another PLA. So we had to set the material. So from that point, why we've chosen one of our material, I think this is logical. We wanted to set the material, so obviously we will take one of our material. Now, So I will just talk about Polymax PLA then. So why Polymax PLA? Why not Polylite PLA? You know, a lot of people say why you have chosen the more expensive PLA of your range. So you know, we have two type of PLA. One is Polylite PLA, which is more regular PLA. One is Polymax PLA, which is nano reinforced PLA, so a tough PLA. Why we have chosen this one? Because the thinking behind the hook design will be different. You can see, you know, Joel telling video, the 3D printing nerd. I think one of his video he tested. I think it was Angus design from Maker's Muse. It's like of how do you call it, a hypercube, or it was like a cube. And then he tried to step on it, and he couldn't break it. And then he put it in how do you call it, a clamp, and then he tried to break it. And you can see the behavior of the product is very, very different from a regular PLA. It won't be as brittle. It would just deform. So I think this deformation is something that is very, very interesting when you design a hook, because you have to take in account that it would deform more than break. If it would have been Polylite PLA, then a lot of design would be very, very different. But I think the thinking won't lead to more creativity in the design. So that was the main reason why we've chosen Polymax PLA.
I have some more questions.
More
What
questions?
are you going with the?
Okay.
People is asking if you are a polymer engineer.
I am not. My background is software engineering, so coding. So I guess I joined Polymaker in 2015, 15 or 16, and I learned a lot. So you know, I like spending time with R&D. Our CEO is a doctor in material science, in polymer science. So I like talking with him. So I learned a lot. Actually, if you want to know a little bit more about polymer science, I cooperate with Sean, 3D Printing General on YouTube. You know, he has a very, very good book about 3D printing. And I wrote a chapter which is called Material Science. And all the thing I learned in Polymaker, I just put everything on there. Like where warping come from. You know, I saw a lot of warping explanation on the internet. And I thought, you know, there might be a lot of different explanation, but I thought the one I learned and the one the comprehension around warping that I developed in Polymaker, I think for me is very logical. So I explain everything how I understand warping, oozing, where oozing come from, what is the difference between oozing and stringing. So I put some definitions. So you can get that book. I think he said it on Amazon, and there is like a chapter on material science, and you can learn about all of these polymers. No more question?
There are two more questions.
Okay.
One guy is asking if are those the 800 kilogram S hooks. So yes, those are the ones that can stand up to 800 according to the provider.
So I guess it's you know, I was also surprised when I received the hook, and it was 2 times stronger than our first hook. But I guess is you know, with metal there's many ways to work the metal to change the like a macro structure of the crystals inside. So I guess by working it in a different way. So I'm definitely not a metal engineer, but I know that our species as human have developed this knowledge for hundreds of years. So I guess they were able to use a material and process the material in a way that is much.
They're heavy as well. More heavy.
Yeah, and we can feel that they are much heavier. So if there is any metal engineer or someone that knows about metal, then can explain this in the chat. But from what I understand, that's this process. Maybe the mind, because they have this learning curve along the way. So I like to have more and more people from the community experiencing a learning curve, because many different things that you do in life is about, like, you know, this learning curve, and sometimes you have like a, you know, how do you call that, like a
stream crashing.
Oh,
Stream stop.
I guess. Can you hear me well?
It's back.
Yeah, it's back.
It's back. Okay.
Okay.
Back.
Stream is not stable like my hook. Yeah, so I hope. Okay. So looks like everything is good. I was talking about learning curve, but so yes, the answer is yes. We'll have some other contests, and we actually started to brainstorm the next contest, which will be very, very, very interesting. So again, stay tuned on our social media. We have seen a lot of people that after the 25th of September have learned about the contest. So please subscribe to our different social media and on our newsletter, because we always try to warn people ahead of time. We are trying to reach as many people as we can. So just stay tuned so that you can be aware of the following contest. And we definitely learn a lot from that contest. So the other contest will be even better. Okay, but
there's only one last question.
What's the question?
Why Polymaker Polymax filament is so expensive?
Okay, so why so expensive? So you can, so it's all about the value you put in the filament compared to the application you have. So why so, well, you know, expensive is relative, right? Like I just said, it's relative to the value you put in the filament. If you do a test on all the TOF PLA, so let's put Polymax PLA in the TOF PLA segment, and then you compare all of them. You will notice one thing, is that when you make a TOF PLA, you will always compromise the modulus of your PLA and your impact strength of your PLA, which could be represented at one side, the rigidity of your material compared to like the toughness or the durability of the material. So you will notice that Polymax PLA is the one. Actually, we have a V2. Which could be even better. But the Polymax PLA is already one of the ones that has the best compromise between its rigidity and its durability. So the fact that we have developed a technology that can bring these two together is the value we put in that product. So if your application is needing this Polymax PLA, then it will definitely worth it. If you are more someone that are looking for more rigidity, for less toughness, less impact strength, then Polylite PLA would be a better choice. And if you're looking for so you don't really care about the modulus of your material, you only care about toughness, then investigate maybe some nylons or maybe even TPU, like hard TPU, if really rigidity is not one of your requirements. Okay, back to the hook.
Back to the hook.
Okay, so S hook, C hook. And the next one would be maybe spirals. So the third one would be all the spiral kind design. I think we've received much more than I thought we would. I was not sure whether this design idea would be very popular. But we have one here, two here, and I know there's a third one here. Is that the one from Australia? Or Australia package is still in the other office?
Australia package hasn't arrived yet.
Okay, so I know in the Australia package, I think there is even more spiral, so let's call it spiral hook. So why I like spiral? Because if you think about it, what if we print just one shell and we just go like this, and then you take that shell and you just, you have the two hook like this, and you just roll that shell around the hook, and then would it be very strong? I'm not sure if it's in the spirit. I don't think it's very in the spirit of the contest, because you are basically receiving a string, and then you have to hook it yourself. So I don't think it's in the spirit. But the idea of here is the same, right? But they successfully made it as a considered as hook. Okay, so S, C, spiral. Next one would be, let's check. Let's say all the, this one. So this one, he's alone in the category for now. Well, he's alone. Does that mean he had a brilliant idea and then that would be the winner? Or he's alone, which means other people think that that might not be the best solution to win the competition. But in any case, he's alone in his category. Yeah, talking about this, we received some people, we received some design that was like hooking our metal hook together and putting a little bit of PLA in between. Yes, it's a smart idea. However, it's definitely not in the spirit of the competition. So Yes, our rule had limitation. We tried to have rules that had at the least exception. But we cannot accept this one because I think it's not fair compared to the other participants. Yes. Anything else?
No.
No? Okay. Okay. So next one would be all the let's say one loop with one closing mechanism. So we have this one. So you can check the closing mechanism. And then we have this one, you can check. So I will show you all the different closing mechanism. Then we have this one, very interesting one. Same, different closing mechanism. So what would be, actually, we can talk a little bit about this closing mechanism. So I noticed there is two different kinds. There is, let me see if I can see any. Yeah, so you have this kind. So you see, this kind is, you know, when you are going to test this, it will, this hook will basically slip out of the inner hook, right? And the good thing is you have some design that have an extra lip at the back that would prevent it to slip out. So I think that is very smart. You know, it's a lot of people has just designed like just one closing mechanism, but it could slip out of the closing mechanism very easily. You can see, I think it was in CNC Kitchen video, in the hook video, he made a simulation, and it was like a similar closing mechanism as this one, and it would slip very easily out of the mechanism. So I think a couple of, I think Race 3D did the same. You see, Race 3D has a very, let me see if I can, yeah, have a very interesting mechanism, because it kind of, you know, it cannot slip, it can only break. So which I think is a very good idea. So this mechanism, this one, you have this one. Let me see, yeah, with the light reflection, so you can see it. So you see, this hook is very thin. I mean, that was the hook that is like 18.7 gram. So I'm afraid, you know, 18.7 gram against, I don't know, another, even a small one that is, so this one is 40 gram. So even this one could have added a little bit more material. But yeah, I'm just afraid this one may be a little bit light to go through more than 1 or 2 rounds. So we're okay here, different mechanism. I already showed that one. Let me check again.
There's a person asking if there any of those has a hole on it.
Hole. So we actually already checked. There's no hook that has an actual hole as we defined it. So there is a lot of like hole like this, but you can see that it's open. You see, so that's why I'm showing all the different closing mechanism, because that's basically that was the idea of keeping your hook open. So all the hooks with holes, we already contacted the participants so that he can change his design. So just to make sure, we are not asking to change the design. He can just modify to close the hole. Why we don't want to modify the design? Because we have already shown a couple of hook design. So we don't want that he completely changed because he had some idea from other design. So he can just like close all of his holes.
A guy is asking, what do we think about his hook, which is this one?
Oh, I remember. Yeah, so that would be, you see, so this hook would be part of the closing mechanism that doesn't have an extra lip to prevent one of the hook to slip out of the mechanism. So
that's Mike Jr.
Mike Jr. Yeah, so Mike Jr., you would be part of this kind of hooks. So the kind of closing mechanism that that don't have an extra lip to avoid the hooks to I mean the hooks of the closing mechanism to slip out of the mechanism. So it will all be about the strength of your actual hooking system to close your hook. Next one is this closing mechanism. Let me check. Yeah, this one, very interesting one. But again, you see, and in this one, there is, it's like rounded. Everything is rounded. So I'm afraid that when you are going to start pulling, it will, easily slip. But actually, this one, very interesting, is you see this part here will prevent the inner hook from slipping inside, or like for moving inside. So it will be all about this one, like slipping out on the outside. And I kind of noticed something with this hook is it was really over extruded. So there is one of actually that brings me back to one of the rule, which we're using a 0.4 millimeter nozzle. Why is that? Because you can make a very, very strong hook by putting a 3 millimeter nozzle or even more, and just like using the more extruder from loose bot and just printing these thick layers, and that would be really, really strong. So some people have went around this rule by over extruding their printing. So I guess like, I don't know, 1.1 or 1.2 extrusion multiplier, and then that would ensure like this there's no air inside. So it's something to test. From some paper I have read, 100% infill is not the strongest the strongest structure. Usually is you have to leave like maybe 80 or 90. So I don't remember the explanation. Well, I remember, but I won't go into the whole detail. But that's something to test. Let's see if over extruding was a good idea to make your hook stronger. So that's another one. Here's another one, like a little bit similar. That's the closing mechanism. By the way, what we are going to put on the social media will have the name and also the number. So if you are looking for the participant you will go against, you can go on the social media and find that number, and then you can study their hook and kind of estimate whether you have a chance against that hook.
They're asking us to show them the Race 3D hook.
Oh, Race 3D hook? Yeah. So yeah, they have a very, very specific closing system. So let me try to show you.
Wait.
Yeah, like this. I hope you can see. You see, there's like, yeah, it's very strange. I don't think I can really explain orally, but hopefully you can see how it look like. So there's yeah, it's not I cannot explain. But during the battle, we'll zoom in so that you can see how this closing mechanism perform on the thing. And I can also see that they so yeah, maybe one thing. Some people have chosen to put the closing mechanism on the side. Some people, like Race 3D, have decided to put the closing mechanism on the extremity of the hook. And actually, now that I'm thinking about this, pretty much all the hooks I have here, I have none of them, or maybe a little bit this one. No, not even this one.
The purple one.
The purple one?
Let me just come here and say hi, because this is...
Yeah, so this is Oriana. So the one that were behind all the emails. So she's the one organizing all of this contest. So now you have a face on
to all the emails that we have exchanged. This is my face. Hi guys. I'll go back to answer the chat.
Thank you. So yeah, so actually I think only Race 3D, or at least from the hook I have now, have decided to put the closing mechanism on the extremity of the hook. So CNC Kitchen is also on the side. Yeah, I think all of them are on the side. So let me continue. Another closing mechanism. You see this one. Again, it will all depend on this upper lip slipping out of the mechanism. There is no extra lip to maintain it inside. Another one, which I mean, it doesn't mean it's better to have the extra lip. I don't know, but I'm just thinking it's a good idea because of the fact that you can simulate what's going to happen, and you can add, I don't know, if you have a few extra gram, you just put something to block it from going out. I tried to design my own hook and participate, but unfortunately Oriana said that I cannot participate. So mainly because I knew the contest ahead of time, so I had more time to think about it. So yeah, I couldn't get my hook into the tournaments. This one feels pretty heavy actually. Let me check. 49.66. So we really have some participants that really use as much material as they could have. So this is the closing mechanism. Very interesting one. So there is actually CNC Kitchen has a similar one. You see like this kind of how do you call that? Like a multiple hook, like a grip. You know, there is multiple hook on the in series. Oh, this one also have the same. Let me check here. You see, there is also like multiple hook. And then, so I'm not sure about this idea. I don't know if it's like you are reducing, I guess the idea behind is you are reducing the amount of force for each hook, which I think is smart. However, I guess this highly depends if all the hooks are stressed at the same time. Because if like you stress the first one first, then it will break, and then the second one, then it will break, etc., etc. So I guess it's a double-edged sword to design like this.
Nico, there's a question. They're saying that you should battle the winner with your hook after like out of competition, and if you could make one, which design would you go for?
So my first design idea was this one. So that was, I think, during September. And then I finally went for another design, which is similar to one here, a little bit similar to one here, but I won't talk about it. I think we already had the idea of having the Polymaker hook against the winner. Yeah, just stay tuned. I think it could be interesting. I've seen some very, very interesting hook. So I don't know, you know, I have an advantage is because I saw all your ideas. So I kind of, along the way, improve the design, and obviously I have some testing here to see like how I can improve the design, etc. So it would be very interesting to after see if even with all of this, whoever the winner is stronger than someone that had all the access to all the idea, access to some equipment, and some of material knowledge to see like how it would compare. But let's continue. So yeah, so another closing mechanism. So that's like a sub level. So it's closing mechanism. Sorry, the other side. So that's closing mechanism with like some kind of grip. And you can see an interesting thing about CNC Kitchen is that you see. Well, I just bite my tongue. Yeah, let me drink a little bit. It's been 1 hour. Yeah, I'm talking nonstop.
Yeah. We're already at 68 minutes.
So, yeah, so an interesting thing is, you see at the back here, he kind of closed the, you know, these two walls on the side are closed at the back, but there is no hole because he kind of created a web, like a bridging on top. So it's not considered as a hole. It's like an open big throat into the material. So a very smart one. Different mechanism. Here is another locking mechanism. Interesting one. Let me check. Here's another one, and we can see. You see this one. He also thought about adding this extra thing in the middle here that would prevent the outer hook to like go outside of the like slip out of the mechanism. So actually a pretty good one here, and feel not that heavy actually. 43.2. So he could have added even more material. Interesting one.
People is asking if we're gonna do another video with the ones that we received on Monday from Australia and America.
You mean another stream? we could. So if there is only one guy asking, or
yeah, only one guy asking.
Yeah,
we can think about it.
Yeah, if there's more people, if there's more people that wants another live with the other, then definitely we can make one. I mean, here we only have 50, and there is 180 in total. So so definitely, I mean, if yeah, just let us know if you are interested, and if there is enough people, then we'll just set up another live next Saturday. So Saturday for us, which is Friday, I guess for most of the people, Friday evening somewhere. Or maybe Saturday for Europe, Saturday very, very early in the morning. Sorry for that, for your weekend. But yeah, we can do another live with the other hook. Continuing, actually, look at this one. Very, very interesting one. Let me get some light on that. Yeah, you see, it's a little bit like similar as the other one I showed you, with like all the different small hook. So yeah, I would be very, very, actually, I have no ideas how this one will perform. Looks heavy though. It's okay, 44 gram. And let me check, and it fits. So perfect. Yeah, I have a good feeling about this one. I'm not sure if the one designing it is in the chat now, but I don't know. I have a good feeling. Let's see. Another one. This one, I think it's very, very interesting. Look at this. So you cannot really tell where are the openings. Well, I think yes, because I can move it. But I don't know. Yeah, I don't know. You know, I was talking about having like a closing hook that would prevent, like with some lips, that would prevent the closing hook from slipping like away. So he designed something that, yeah, cannot really slip. Yeah, I don't know. I don't know how this one will perform. So this one, the slow-mo, would be very interesting because I think it will break before slipping apart or like let go. But another interesting design. So let me show it a little bit more. Yeah, so that's the difference. Very, very, very interesting. Okay, let's continue. Oh, I forgot the C hook. Hey, there's a big hole inside.
That one is disqualified.
Oh, okay. So this one was disqualified. So
but he did send another
STL. So without the hook. So this is an example of a hook that was disqualified, and we contacted the participant so that he can remove the hole. But yeah, so it's not only about having the hook inside, you know, the hole inside. It was also anywhere you couldn't have a hole. Why? Is because you can easily save material by putting the hole. So you have to be a little bit creative to get that. So I will put this one away. Another, yeah, very interesting one. So this one is kind of it's a closing system, but in 3D. You see, kind of. Yeah, you see that? So it's kind of yeah, going like crossing each other, but in 3D. So a very interesting one, and it's kind of, so it's using the C hook idea of having like a mass material that would prevent that would go against the stress, but at the same time having like a small closing system, so that it can like divide the stress between the two. And you can see the hole inside, but it's not a hole, right? It doesn't go all the way through. It's just like he just carved something to remove some material from inside. So very yeah, very smart. And he used bridging, so no support because of the support removal post-processing. But yeah, so yeah, so that was the scene. So this kind of goes in the middle. Okay, a few left. Yeah, this one, very, very interesting. Did I show that one again? No. You see a similar locking mechanism as Race 3D, but on the side. You see, and with the extra lip here that allows it to stay in place during the stress. And you see, even the lip is actually using a C hook like idea to maintain the lip in place. So very interesting, very interesting. Going forward, we have this one, okay, so this one is nice locking mechanism, similar to some others. The race 3D I already showed you. This one is the spiral one. Okay, we have a few left. So these two are very interesting. So it's a mix between spiral and locking mechanism. So they kind of, they mix the two ideas. And this one is similar. It's also spiral, but with two locking mechanism. So yeah, very looking forward. So let me check. 45.5 gram and 48 gram. So let's see. This one are very interesting as well. We have an S hook here with a locking mechanism. And oh, this one. Oh, it's for our other. Yeah, this one we need to check because I don't know how to put the hook. Maybe you can check there. So some people have a very strange way to put the hook. So we can we can check.
In the
because like you need to like for example the green one at the beginning we couldn't put the hook, but actually there's like a certain way you have to put the hook. Okay, so another one here, interesting hooking, closing mechanism. We are arriving to the end. Another one here. I think there's some. What is that? Mine is a cherry picker with a gauge went over 1,000. It exploded at failure. Safety measure. Yeah, definitely. Well, we've seen some. There is some like a YouTube video of people testing their own hook, and yeah, we had some very smart testing design, but definitely be careful with testing your hook. So the first, so something that's yeah. So you see, we can fit this hook, but yeah, it needs to be we need to follow the yeah, we need a certain way to put it, but that's how it would look like. It's funny, it's like a snake. Yeah, and that's the other one. It's like a snake around the different hooks. Like very interesting. Okay, I was talking about something. I don't remember. Another one. This one very interesting as well. Let me check. Put about the light. We have how do you call that? The thing the policeman use, handcuff. We have a handcuff here. Very handcuff design, let's call it. Very interesting one. And this one is interesting. You know, there's no like locking mechanism in a way that there is like some hook that kind of close it, but in some ways it would like self-lock by opening. Yeah, I'm not too sure. So that's why we are going to record everything properly so that we can see how each hook behave. Another one here. Very interesting one as well. This one. So this one, yeah, actually this one we need to check like where we put the hook. Because,
yeah, they send the
I guess.
information.
Is that like one in, one out, or just? Yeah. So this one we need to check because if we only put it here, then I'm afraid that that it will break pretty easily, or maybe what? People
is breaking their cars to test the hooks.
Yeah. Breaking their cars. Yeah, just be careful. Actually, I have to say we were not expecting to have to go to this amount of stress for 50 grams of PLA. So I think, yeah, let's see if we can reach the tone. I don't think so, but let's see if there is any of these hooks that can reach 1,000 kg of load. Would be very interesting. Like 50 grams of PLA, 1 ton of stress. Yeah, and that's the last one. Yeah, there's no no category for that one.
I want to see this one. Is this one the one that you want to see hooked up?
Yeah, but I don't know.
I know how to put it.
Oh, like this.
Yes, and then this one.
And this one goes. Oh, sorry.
Yeah, so it pulls on the S.
Oh, yeah. Oh, so actually, it's a S hook. It's actually a S hook. S hook, but with some extra art to it. Yeah. So this one come from where?
The light blue one. The one that you were mentioning before.
Okay. I think this one is from Japan, right?
I think it's from Japan, yes.
Yeah, so this one is from Japan. I have a couple of them from Japan actually here. By the way, who is from where? Do we only have the US here because of the timing, or do we have maybe Japan? I guess in Japan is 12:20. How about the other? We have Germany, Texas, Finland. What time is it? It's in Finland. USA. How heavy? How heavy is this one?
Texas, Colombia. Hey, me
Colombia. Where? Oh yeah. What time is it in Colombia?
12 hours, 13 hours less.
Germany, 5 a.m. Well, thank you for joining.
10 p.m. in the evening.
10 p.m. Okay. US, Central Time, US, California, US. 6 in the morning. Thank you for joining.
Let them know we are in Shanghai.
USA, where are you? Yeah, we are in Shanghai. We're based in Shanghai, so it's 11:20 here. UK, Florida, 10 p.m. US, North Carolina, California, 5 a.m. Wow, there's many people at 5 a.m. So are you guys all participants? Or is there anyone that couldn't participate? Or you all have your hook in the tournament? So actually, have you seen whose hook you are going to... so do you have... Yeah, is there any hook here that you don't want to go against? So I know some people would be on the, like have one extra round. And yeah, I'm wondering if everyone here are on the brackets, or if there anyone that is just interested in saying which hook is gonna win the whole competition. Yes, mine is a huge one. Oh, is that one of the, is that this one? Or this one? We have two huge hooks.
Brian wants to see the light blue one. Might be a real contender because
the light blue one?
The hook is supposed to loop around the middle. So I believe it's either the handcuff or this one.
This one? These two one? Or one say he doesn't want to go the spiral one. Yeah, actually the spiral one, I'm not sure. I think they are good ideas, but I don't know how they will behave. You know, I don't know. Yeah, I have no ideas. I'm really excited to see how this all the spiral one will perform. Definitely one of the first idea I had, but not sure if it was the best. CNC Kitchen has a very good chance. Yeah, let's see. You know, I've seen a lot of people talking about Stefan. That I saw a YouTube comment that says that CNC Kitchen prepared his whole life for this competition, which I thought was funny. But let's see. I have a good feeling about the hook, pretty sturdy, like following the 8mm rules, having like a very nice idea here of closing his closing system, but without having a hole. So yeah, I don't know. We may be, I don't know, maybe Race 3D against CNC Kitchen will be the final, or I don't even know if Race 3D. Oh, it was that one.
I have to look at the.
Yeah, we can check.
Yeah.
I don't know if Race 3D and CNC Kitchen are on the different, like a different bracket, and then they will meet in the final. Or I remember, I think they are on the second part. So if they meet, they would meet in the semi-final. But the good thing is that the spiral one, I think they are wet spread, like on the 64th. So if they are good hooks, then they will meet in the final. But now another thing. Let me tell you this. Another thing to take in consideration is that the hook has to handle all the different rounds before arriving to the semi-final. So maybe the spiral one will be very, very strong at the first one, but maybe as soon as this like small hook here, the small hook like will break, then maybe the next round will be a very, very easy. I don't know. Is there any question?
But we have to double check.
Yeah, so we need to double check how to use this hook. Yeah, not sure how it works. You see, like you have to put like this, and then around, and then put like this, and then it fits inside. So it's a little bit like you know, the, how do you call that, the puzzle? You know, like some people, they send us a puzzle where we have to put the hook inside. So we kind of try to figure out how to put it inside, and then how to put it like getting out of the hook. You know, like this kind of puzzle where you have like this metal thing, and then you need to remove it and then put it back. Mm-hmm. So similar. Okay, so I think that was no more questions. So I think that was all the different hooks we have at the moment. Like I said, if there is anyone that wants another stream next week with all the other hooks, we could organize this as well. But there will be much more hooks, right? So we may not be able to show all the different hooks, but there might be some like different design style. So today we have seen like S hook, C hook, spiral one, like the self-locking one. We have seen some handcuff style, some like multi, like many different hooks style. I don't know how to call all of them, and some very light, very light hook. So yes.
More questions. How did we create the brackets? So we completely like we use the.
Yeah, so we use a software. What is it called? Yeah, so we use a software, and then we put the list of all the people, and then they generate randomly the brackets. And actually, this software we can use it. You can go and check it live, and then as we do the different battles, then it will automatically go down the brackets. So we will post the link of that live bracket tournaments, and you can follow. So it's a special website that offers this feature. So everything was random. When do you think the picture will be up? Monday? Is that Monday?
Monday we get all of them. Yeah, we start publishing this.
Monday. So we will start putting on Monday, because all of these we already have the picture. So we'll put on the other one. Will arrive on Monday, so we need to take the picture. So I guess towards mid next week, end of next week, because there's like 181 different pictures that we need to post. So we just group them like an album on Facebook, or like group them by 10 on Instagram, or maybe we'll do like some mosaic of pictures. On Twitter, we can post on Twitter. I think on Twitter it's up to 5 pictures. Is that right?
Yeah, it's smaller bundles.
Yeah, 5 pictures. How many weeks until it's all over? Good question. So that would be around 4 to 5 weeks. Yeah, 4 to 5 weeks, two video a week. So what we didn't want to do is to do all the tests ourselves and just go and then say, okay, this one has won. So what we wanted is that, a lot of people put a lot of time. So we want to put a lot of time into making nice video, to record everything, to explain everything, to like explain the behavior of each hook, so that we can give back all the time that you have put into designing your hook. Polywood competition as next one after this one. So Polywood is more for like aesthetic material. We need to thank, because there's a lot of competition out there which is design the most beautiful this, the most beautiful this, or the most useful this, the most useful this. But what we are trying to do is to design some kind of competition where there is this extra excitement of competing with the different design. So you can have, I don't know, some design where it needs to protect against an impact against each other or something like this. I have 2 and 3 sitting here. Okay, so if you have many 3D printers, just keep printing. Yes, I'll break it. So let me just read quickly, and then if there is no more question, then we'll just end the live. I've shown all what I have here. Please include hooks names with pictures so we know which name goes with which hook. Yes, there will be the name and the number, the bracket number. Your bracket entry is clear for rules. I need to order a ton of filaments. Please do. When posting the picture, please include the hook name. Yeah, you beat mine and Solvent. Hang on. Okay. When does it start? Yeah. So like I said, Tuesday in 2 weeks, right? So every Tuesday and Thursday we will release all the battle videos. So we record everything. We will edit all the video, and then we will post every Tuesday and Thursday. Okay. What's the largest roll of filament you sell? 5 kg. So 3 kg on our website, and then 5 kg for special order. So I will stop there. So maybe we will have another. So that was the first live Polymaker has made. So it's the first time we connect with the community live, except from shows. We usually go to all the main shows, but that was the first time we connect via live stream. So I guess we'll do this more often, answering different questions. We might have some live that is more technical oriented, where we talk more about 3D printing as a like a technical tool. We can also talk about our materials. I can present a little bit about what's the difference between all the different materials, which application requires which kind of material. When you select a material, what kind of properties do you need to look into? Maybe I can also explain about, you know, what's the mechanical properties like? What does it mean to have a strong filament? What does it mean to have like a rigid filament? So that, you know, we have our TDS for each material, but you need to be able like to read the TDS so that you know like what requirement you have for your application. So that was it for today. I think get everyone to explain their design. Yeah, we can have, actually we have an idea is that semi-final and final, we may have an interview with the participant that designed the hook. And then we will also publish this so that kind of he can explain us like where he had the idea and how he considered his design. And also like maybe what printing setting, what printer he used, etc., etc.
People is asking us if the hooks posted in the brackets have been checked for the rule compliance. Yes, well, we have checked them by the pictures. We just need to check them.
So yeah, we checked everything from the picture. We will still need to do a weight check. We believe, because like we have received all of these and all of them are within the rules, so we believe there won't be any problem. That there might be 1 or 2 that will be removed from the bracket, but most likely not. Okay, so I think that's it for today. Thank you everyone for joining our very first stream, and we will post on social media whether we are going to have another stream on Saturday with all the other hook. Thank you for everyone that joined, even if it's very early in the morning or very late at night. We are in Shanghai. Some people are in the US, some in Japan, Europe, Australia, from all over the world, which I think is fantastic. So thank you again for joining today, and I see you in the next stream. Thank you.